presentation on the drilling market. Up. You have to open the second presentation. So as I mentioned, we will give today just some updates on how the market is developing, because we will present the market report 2022 later, end of May, early June, when it will be officially published. At that stage, we have collected all the market data from the different countries, from 30 countries all over Europe, and we will report them properly in May and June. So today, just first some information. What we can say that we have seen that more than 30 wells will be drilled in the 3 to 5 next years for geothermal electricity, which is quite new if you see the recent market developments outside Turkey, of course. For heating project, it will be more than 100 wells to be drilled and have been already announced in the phase of project development. And you will see the figures, even more projects are under planning and will require even more wells, technologies and drilling capacity to be developed. So today, what is the situation, not in 2022, but at the 1st January 2022, not at the end of the year? So 142 power plants. There were 6 new in 2021. And the capacity is 3.4 gigawatts all over Europe. You could see it's in blue in the map, and with nearly 20 terawatt hour of electricity production. So a good load factor, more than 84%. We have 364 geothermal heating systems in operation. It was 13 new in 2021. And I say for 2022, we will announce that end of May. The capacity is nearly 6 gigawatts thermal installed. For heat pumps, we also mentioned that and covered in the market report. We have 2 million geothermal heat pumps, but you see it was a record year in 2022 for geothermal heat pumps, all kinds of systems, including large systems. So just when we see new market development, it's always good to see what was the last decade, the last 10 years. And if you see the last 10 years for electricity, the capacity mainly grew in Turkey, a bit in Italy, in Iceland. But what was interesting is also new countries have also developed geothermal electricity, especially Hungary, Croatia. So what we see in electricity, that indeed it was required a drilling engineering, drilling capacity in Turkey for many decades. But what you will see in the market report is that Turkey will continue to grow, but we'll see new countries also developing geothermal electricity projects, and we expect especially new interest in Italy. If you look at heating and cooling, what is interesting in heating and cooling, because it's different than electricity, where electricity, the number of wells to be drilled are really depending country per project per project. In heating and cooling, normally we have a traditional doublet system, but you will see, let's say normally, because there are some new developments next year, and already this year, so in 2023. But you see, on average, you have 15 projects per year, including extension. When we say extension, it's especially in France, where there's a triplet. It was not developed as we could expect in France, but there were still some triplet developed. So a third well for the extension, but typically the doublet. So when you have 15 projects per year, you expect 30 drilling per year, 30 well drill per year. And we hope to see a slight growth in the near future on the number of wells and projects developed. What is interesting is where they are developed, and contrary to electricity, the development of geothermal drilling capacity for heating projects is all over Europe. We need that development all over Europe, and I will not go to the detail of the map, but you see that it's really all over Europe that we have development of projects. What we do in the market report also interest for you, for the drilling engineers and drilling and drillers and all the people involved in drilling, is that we also look at what stage the projects are. We know that we need 3 to 5 years for geothermal district heating, 5 to 7 years for geothermal electricity. And in the market report, we try to see, and you could see that you have nearly half of the project in planning and exploration. So before the drilling phase, when I was mentioning that you have 100 of project development, so nearly half of them have not yet drilled. So they will need soon this drilling capacity available. And when we look at that, and I hope we'll have a good discussion today, it's different depths and different temperatures all over Europe. Also in the market report, you will find also what is the average depth drill all over Europe and at which temperature you find the brine when you drill. For heating project I mentioned. So the conclusion of my presentation, short presentation, is that indeed, while we assess more than 30 wells, in electricity, we have 25 plants under development all over Europe. Construction or extension. When I say all over Europe, it's including Iceland and Turkey. And there's one project investigated. So here, when we say 5 to 7 years, it's more at a long or mid-term vision. We can say 5 to 7 years. They are still at the phase of investigation or licensing and not yet ready. For heating and cooling, it is much more promising. Why we mention 100 wells? There are already 16 projects in the drilling phase or about to drill. When we say that, we mention, as I say, many doublets, but you know that a company in Denmark, in Argy, announced for one district heating 19 wells. So it's not only a doublet here, we speak about a lot of wells drilled for one single project. It's quite a big project. It will be one of the biggest projects in continental Europe. We will see some extension with triplet, still, I think, only in France, but maybe in the near future also elsewhere. So in top of the 16 projects already ready to drill, we have mapped 337 geothermal heating projects developed or investigated. So you can see the number is huge. Not all these projects will be realized, but the interest in developing this project is huge. As I told you, more than half of the projects are in the permitting or investigation phase. So we need you. We need all of you, the drilling engineers, drilling designers, drillers, to operate this project successful. I will close here my presentation, and it's my pleasure now to give the floor to the first moderator, my president from EGEC, because on it, but here is speaking as ETIP Geothermal co-leader on well technology. Miklos, the floor is yours.
Yes, good morning, ladies and gentlemen. Welcome to this webinar, which it has a great interest, as Philippe said. And in fact, I'm just a co-leader of this working group on geothermal drilling, and my colleague Laurent, who is the leader, he prepared a few introductory slides on what is the aim of the working group on drilling within the European Technological Innovation Platform Geothermal now, and he will I give him the floor to say a few words on the progress, on the scope, and what is our role as working group in the strategic research agenda in writing this, because this determines the future of funding for innovation, essentially for geothermal and especially for drilling. Yeah, Laurent, floor is yours.
Okay, thank you. So, Christina, I don't know if I have to share the slides.
I can share for you, Laurent, if you prefer.
I can try. I'm going to try that. So I guess I have to share my screen. Okay. Can you see the screen? Can you see the slides?
Yes, we confirm.
Yes, it works great. Okay, so I'm going to try to make this thing work. Okay, it seems that slides don't move, obviously. Where is? Okay, right. Yes, it works. Sorry for that. It works now. Yeah, many thanks, Miklos. Actually, yes, we were both co-leading. I'm just a co-leader of this work group, as same thing as what Miklos has just said. and we worked the both of us on this work package, which was quite a work. I would like, of course, to thank Miklos to share this colleague with me and for the work that was performed. And above all, I would like to thank the 50+ people who actively brought their contribution to the preparation of the document, the strategic research agenda. So chapter number 2 about drilling technologies. We had people.
Hol meinen wieder raus.
Can you hear me? Can you hear me?
Yes, I confirm. So it's why I ask, please, I ask really all of the attendants some discipline. Please mute yourself and allow the speaker to deliver his speech properly.
Oh, sorry, I thought there was an issue there.
Exactly.
No, okay, thank you very much. And people, so I said people who contributed and coming from various domains, that could be the industry, contractors, research, academics, research institutes, and so on, which various angles of view. And at the end of the day, that's lots of ideas that may be frustrating at the end of the day to see that we couldn't put everything, absolutely everything in detail in the SRIA, but the idea is to give trends, order of magnitudes, and to try to see where we want to go. And it's not maybe not the goal of the SRIA to deal with details, but it was extremely important to have all those angle of visions to manage to put some trends forward, and I hope we managed there. Just a reminder maybe here about the strategic research agenda and to see where we stand. As you know, the ETIPs are technical and technology and innovation platforms that were set up to feed the set plan, strategic energy technology plan of the European Commission. And in this frame, we are producing this strategic research and innovation agenda to help to shape a strategic research and innovation plan and to define research and innovation priorities. And this is where we stand. The topics on which we worked are here on this slide. I will maybe not go into detail for all of these topics, taking into account that some of them were quite important in this discussion, in the discussions at the end of the day when we talk about robot and AI-assisted drilling technologies. When we talk about materials, we talk about drilling fluids. So, and you imagine that all these are, let's say, the pieces of what is going to shape, or what is making the shape of the drilling of geothermal wells at the moment. What is very interesting is the way all these topics are interacting, I would say, to materialize some trends, general trends that are very interesting that we try to spot in this chapter on drilling technologies. A few insights maybe about these trends. First, we have the technology transfers from the oil and gas industry, which are very important to gain really in our ability to drill wells and to gain in performance, with a bit of caution, because we have businesses which are not exactly the same wells. So we have to be cautious about what we take from the oil and gas industry, which is very important, how we adapt and how we take into account the specificities of the geothermal. The gain in productivity, which is a key issue, the economic part and financial part of the thing is one thing, but we realize that if we want to gain in productivity and optimize drilling, one thing is to know a bit more, not to say much more, about the ground, the terrain we are going to drill, which means lots of works in terms of exploration, modeling, and methods, and anything that can help us in terms of workflow about identifying and understand the uncertainties. Also, it's a very important thing regarding the rocks we are drilling. From an industrial point of view, we can think also about the fact that pushing geothermal toward industrial and standardized projects, we need to define properly which kind of wells we need, where the priorities are, and this is also that was a part of the discussion. And I might add, among plenty others of discussions that you will find maybe between the lines of this chapter of the SRA. One topic which is very important, it was mentioned, the fact that 40% of the energy used in Europe is in the form of heat, and that's really a trend that we have at the moment, and Philippe mentioned that. So this is where we stand, and we might now have presentations on topics that or projects that really are the small pieces that are pushing us into the right direction, I would say, regarding the trends that the SRA has tried to push forward and to figure out. So Philippe, maybe, and Miklos, if you want to introduce the next sessions, and I leave you the floor.
Yes, thank you, Laurent, for this overview on the working group on drilling technologies. As you could see, there's not only drilling proper, but everything which is in the well, including the pump. And
absolutely.
Yeah, and then what is important also, technology transfer, which is not only one way from oil and gas to geothermal, but is in the other way around. We could see that our specificity related to high temperature is very, very welcome, the development also in the oil industry. So, well, I propose to go to the first session, which is addressing drilling design and technologies. Well, we had a quite big interesting participants, so we managed to put up 9 presentations for today. If we would have had the whole day, I guess we would find people to fill the whole day of presenting about drilling, which is a great achievement, as showing that there is a great interest towards this discipline, which is the essential for getting the heat up to the surface from deep. Well, our first speaker is Janahra Karimbi. He's a drilling professional, and he will talk to us about new geothermal energy drilling and innovation. I'm sorry if I misspelled your name. The floor is yours. Please put your microphone on. I guess I learned also that you have a translator because you are from Iran. Problem.
Mr. Karim, you are muted. Can you please unmute?
The microphone is mute on your side. Put it on. Oh, we don't hear you. We don't see your presentation.
So maybe I will share the presentation, and I'm waiting for him for a microphone. I can share it.
Yeah, you can pass him a message that that his microphone is off.
Have you my pages? Have you my pictures? Hello?
Yeah, we don't see the screen. We hear you. Okay. We hear you now.
Yeah, my computer has a problem. Is it possible you share my proposal and then I explain them on? Is it possible for you to share my proposal? I have sent them for you. My computer has a problem. Sorry. I am trying. Have my picture? Have you? Okay. Wait.
Yes, okay, I confirm. I will share your presentation.
Yeah. Okay. No. Wait a minute, please. Sorry.
Yeah, here it is.
Here it is. Okay. You see it? You see my presentation, my pages?
Yeah, everything is okay. Please
Okay.
go ahead with your presentation. You have 10 minutes.
Thank you very much. Hello, everyone. My name is Can Karimi Birgani, civil engineer. My proposal design is about new geothermal energy drilling innovations and also resistance of geothermal energy piles subjected to earthquakes and liquefaction phenomena. My view at the proposal plan is from the perspective of engineering, earthquake engineering and geotechnics. The proposed project aims to address three primary objectives related to geothermal energy systems. Firstly, it seeks to innovative of geothermal energy piles, particularly those constructed with steel casing, to horizontal and vertical displacement induced by earthquakes, forces, and liquefactions, induced by earthquake forces and liquefaction. This objective is crucial since it will provide insight into the behavior of geothermal energy piles in seismic area, which is essential for their safe and efficient implementation. Secondly, the project process an innovative design for geothermal energy extraction using inclined wells instead of the traditional vertical wells. This design is focused on achieving efficient, sustainable, and economically and environmentally friendly solution for the construction industry. The proposed design can extract geothermal heat from depth 4 to 8 kilometers and areas of 5 to 10 kilometers in diameter beneath the ground surface. The proposed design is adaptable to different soil types. Finally, the project aims to optimize the productivity of geothermal energy systems by reducing land use and extraction cost compared to conventional methods. The proposed sign is also applicable in areas prone to earthquake and liquefaction, attending investors due to its safe and affordable return on capital. In conclusion, the proposed project aims to investigate the behavior of geothermal energy piles under seismic conditions, propose an innovative design for efficient geothermal energy extraction and optimize the productivity of geothermal energy system. Achieving these objectives will contribute to the sustainable use of energy resources and promote the development of alternative energy sources in safe, economical, and environmental friendly manners. The proposed system consists of 12 piles or more T18 that generates geothermal energy and inject cold water into the reservoir, of which 8 are dedicated to energy geothermal generation and four or more for water injection. These piles are drilled into the ground until they reach the geothermal energy reservoir. On the surface of the earth, The group of piles form a symmetrical cone-shaped structure that is designed to resist changes and displacements caused by seismic activity and liquefaction. The piles are interconnected through a pile cap or mat foundation that provides through additional stability and to the system to resist the horizontal and vertical movements of the crucial structure. Horizontal inclined braces have been implemented. These braces are designed to distribute forces eventually throughout the system and reduce the risk of structure damage or failure during seismic. The proposal system is designed to efficiently extract geothermal energy while maintaining sustainability and safety during seismic events. The use of inclined braces and a symmetrical cone shape helps distribute forces and reduce the risk of structure damage, ensuring the continued operation of the system even in areas prone to seismic activity and liquefaction. In conclusion, proposed system utilize 12 piles or more to generate geothermal energy and inject cold water into the reservoir. The system is designed to resist changes and displacements caused by seismic activity and liquefaction through the use of horizontal and inclined braces and a symmetrical cone-shaped structure. The proposed system is an efficient and safe solution for geothermal energy extraction in areas prone to seismic activity and liquefaction. Thank you very much. My speech has been finished. Is there any question? I am ready.
Yeah, well,
my computer has a problem to share my.
Yeah,
Okay. Did you see?
Yeah, thank
Okay.
you very much for this nice presentation. Well, as we said at the beginning of the session, we are going to have the question and answer
Thank you very much.
at the end of the presentation.